Good evening, Professor. So this is the assignment 6, building cloud native application from ground up. Sharing screen. Yes. So here it is. This is the cloud assignment 6. Right. So I just want to say that it's a very great opportunity, this exercise, because it allows the app to go straight into Node.js, which is cloud hosted, So whatever apps we have, generally in Apache or Nginx, we have a traditional website, so this can go here. And I had an app in Apache and Neo4j database, but that's also crashed with that VM. So I had a plan of what to do, but so that's the first part of bringing it to the cloud. We packaged with Docker, we deployed to Kubernetes with Helm, ran to scale. So I did this part and this part, and then it crashed. So I will show you what was done because I was able to get screenshots. And then we enhanced with cloud capabilities. So I went through that tutorial of microservices. I captured some very interesting things that I found were very important to me. One is that Express is IO speed is faster compared to Spring Boot, and its startup time is very less. Spring takes very long to start up, and memory, it's much more efficient. So I'm very happy to learn this about Express. The second thing is I found that cloud hosted, there are many, but very few use Docker, and very few companies use Kubernetes, only 12%. I got the landscape chart for applications that are very close to Kubernetes, and we can actually choose what we want. And I just want to show here that we have many choices actually that are in incubation, that are being created. And you have Kafka, Kube, MQ for message queues, and then you have orchestration, you have Kubernetes, and then Contour. You have the companies that are using it, and then you have all the runtime, CMCF, incubation graduated, and yes, and here you have the automation, the container registry. So this is so beautiful to know that there are so many. SparkQL, yes, I used Hadoop, SparkQL also, and I've used Neo4j, what do you say, databases. So here we have MariaDB SQL Server. Yeah, that's right. Neo4j is here. So that was my application that I was going to, what do you say, bring up to the deploy to native cloud. So this is how we start the npm Express. So we do npm install Express generator, and this installs npm Express -h. Then you do Express MyApp. So this part creates the MyApp folder here. So it creates all these folders here, very systematic. Cat package.json, npm install. Then we have npm start. This starts it off. We can start it in the background as npm start ampersand. So we can have the session. So this opens up the Express port at 3000. Yeah, so Express goes to 3000. Now we install the Node.js Docker file. So this is the part where it becomes cloud native. So we get a Docker file, we do wget main Docker file, and then we go into the Docker file, and it gives the instructions how to deploy this onto a Docker container. So we put the 3000, the port, and it has 3 ports actually that are expressed in the npm start, and this one. So actually, from here to here, is what, yes, only execution copy downwards is what we will actually use to build a new Docker image. So we can even have a docker.ignore file, So it ignores the top part and only installs from here and the copy downwards onto any machine you like. So it will build a Docker image of whatever and Node.js application you have. So now Docker build this, and don't forget to add a period, otherwise it'll give an error. And T is tag, what you want to tag it. And so this builds this Docker image right here. And here's the Docker image. And then here, if you do image ls, yes, you'll see node server. Here's the image ID. They created this, So the Docker images are here. Now we can run this, and then we have our 3000, 3000. Now the first 3000 is the port on the Docker machine, and the next 3000 is the mapping to the local machine. Yes. So that's how this is expressed. Ports are mentioned, and now we get an error from the Docker saying failed an endpoint. This is new in use. Right. So we're going to install another one, and actually, though I ran it on this, I did not. I went and stopped the npm process. That was previously running. So once I stopped it, I was able to again run it at 3000. So it was running at Docker was running at 3000. I just killed the older process. Yeah. So welcome to Express. Now in Node.js, integrated with database Kubernetes, multiple instances in the same container. So I have a very good diagram to show what Kubernetes does. So with Docker, we take the Node.js app, we package it all of this, and we deploy it to many servers, many instances. But then to coordinate with database and other apps, we use Kubernetes. And also it adds authentication, monitoring, and logging to it. Also, it does self-healing, it restarts on failures. Now, running Kubernetes. In the tutorial, the person right-clicked Docker for desktop, but that was on MacBook. But I had to install it myself. So I installed all these. Here we go. Here's the output. Yes, make it Kubernetes. Then I did this curl, and then ran the G. This is the what do we say? Essentially, checksum from install this kubectl, and then kubectl version. Kubectl cluster info. I got this error. Connection is refused to the right port. So I was deploying it to Helm, and and here's Helm, the project manager. And for Helm, the thing is, the tutorial said use Helm in it, but it's removed. It's not required anymore. Also, no tiller is required because in the tutorial, the speaker was saying install tiller, but it's not required anymore for this new Helm. So this is a new Helm hub. So I brought this, and what Helm does is I was able to get from GitHub. I was able to get the template for Helm to, and that gives 3 very interesting files called chart. It's in chart. I'll show you. Yes. So in chart, we have 3 files. One is the values.yml, one is the chart.yml, and from chart, it's able to chart out the execution, So this is what I had to install Minikube locally. I installed Minikube. I got this error. It requires contract to install, so I got this workaround and installed contract, and then there were these files in the temp Juju files. So I had before starting again Minikube, I had to remove them, check them, and then start Minikube start driver and starting Kubernetes in the background. Then Kubernetes status kubelet. So kubelet was up and running. You can see it in green. And then I had to take off. We created lots of firewall rules. The firewalls, UFW, there were so many firewall rules. Docker created it by itself, and then we drop all going to anywhere, coming from anywhere. And then Kubernetes also had its own firewall rules here. So I didn't create them, but they were all created automatically. So I had to go that. I just disabled the firewall rules, so I wouldn't get any errors. Then what happened was I was installing this, and kubelet had to be configured, and so I had to run system status kubelet, and I enabled the servers, and at this point it crashed. So I was running this. It was taking a lot of cycles, CPU cycles, and I opened another session so I could work on SonarQube, and the whole thing crashed. So that's and after that, it could not even come up. That machine, the new DevSecOps 3. So I had to stop it, and my original app also is there. My Neo4j is also there with my Apache front end, which I have to plan to bring it up to the into the cloud, native cloud Node.js Express. But I had planned what to do, and though I don't have the server now to build it, I would need some time to do it, and I could easily show it to you, Prof. But this is what I was able to do, and it unfortunately crashed. I couldn't bring it up also. So this is what I have, and but if but if I were to build the native, bring up my Neo4j and my application into this, I would first put my app into Express and Node.js, and then I would use Kubernetes later to map the database, to orchestrate the database here with the with this, and then put in all the monitoring and Grafana and all that. But unfortunately, I can't do it, and it made VM just stop and wouldn't come up several times, though I tried. So thank you, Prof.